All right, guys, so now the last part is subtracting rational functions or rational expressions. This right here is what I've been talking about as far as where parentheses is very important, okay? So first of all, let's factor what we have because the approach has a lot of similarities with adding rational expressions, okay? So we're going to first start by looking at what are the denominators and numerators, and we're going to factor everything. Okay, so let's go ahead and factor the denominator on this first one. We get x minus 2, because again, we wanted to take out the GCF. What is the biggest factor that these two terms have in common? Okay, we're going to do the same over here. Well, there's a 2 that is in common here, so we're going to have 2 is factored out, and x minus 2 are the leftover scraps. We still have x plus 2 in the top. Now, this is a subtraction problem, and we can tell right now that our denominators are not common. Okay, remember, when we add and subtract fractions, we need common denominators, and they are not common right now. Okay, so this first one is missing a 2. So the 2 that's right here is missing over here. So I'm going to create a form of 1, which is 2 over 2. And now, so far I have this is in both of them, this x minus 1 binomial. I now have the 2's are the same, but now you can see I'm missing this x in this second fraction. So I'm going to multiply by a form of 1 over here on the second fraction, which is x over x. And now, color coordinating it all, you can see everything is now common. As far as my goal was to get my entire denominators to be the same, which it now is. Okay, so now let's see what we do from here. Because it's a common denominator, I now have one huge fraction, okay, which is 2 times x minus 2. This was my common denominators. Here and here will now combine as just one of the same denominator, okay? And yes, multiplication exists in between these pieces right here. Now, we have to simplify. What does this become? Well, this will become a 2x plus 4. I'm going to go ahead and do that now and distribute so that you can see what's happening. And then this one right here, I'm going to go ahead and distribute. Okay, so x, because there's no parentheses right here. Okay, these parentheses are not drawn, but they're very, very important because this will distribute and become x squared plus 2x. Now, watch, guys. Here's the catch. This subtraction goes here, but it's so super important that it knows that I need to subtract everything over here in this entire piece. So because of that, the most important parentheses are located right here. This negative will distribute on both of these so that it becomes a negative x squared minus 2x. Okay? All of this became a negative x squared minus 2x. This over here, it's still the same. It's still 2x plus 4. And it's all over the same common denominator of 2x and x minus 2. Okay? That's what's going on right now. Now, let's look at what we had. We were subtracting this fraction, and there's an addition here. That's why nothing really happened here as far as a negative wasn't distributed here and here. It was just the 2, and that's how I got the 2x plus 4. Okay? Now, when you get to this piece, when you've simplified the top where there aren't any parentheses, you now want to combine like terms and reduce. Simplify, combine like terms, reduce. Simplify, combine like terms, and reduce. It's like a pattern over and over and over again. Okay? So let's simplify the top. Combine like terms and reduce. Well, those two x's will cancel to a form of 0. Not 1, because they're not dividing, they're adding. So they will cancel to a form of 0. It's almost like they just go away. Okay? So that I have this 4 minus x squared is left over up top. Okay? And here's where the negative mistakes start to occur. It gets a little bit interesting here. Okay? So if I looked at 4 minus x squared and I wanted to cancel, factor, This is like 2 plus x squared, 2 minus x squared. It's like a difference of squares. Oops, not x squared, x on both. It's like a difference of squares. Okay? If I did it that way, and I factored the numerator to this that you see right now, and I kept my denominator as 2x, x minus 2, the question here is, do these cancel? Since they don't really necessarily look the same, do they cancel? And the answer is no, they do not cancel. Okay, they have to look exactly the same. And because of that, watch what I'm going to do. I'm not going to look at it like this. From here, you see the 4 is listed first, and then the x squared is listed second. I'm going to write it like this, x squared plus 4, because there's an understood positive right here that I can just rewrite it commutative property. Okay, so 2x and x minus 2 is on the bottom. So it's still the same. All of this is still the same as all of that. But now look what I can see here, is I can see, is there a way that I can, from this step, a lot of people struggle with this step, okay? And it happens whenever this backward piece is trying to cancel with this. That's when you can identify, oh, it's that negative GCF occurrence, okay? So if I'm looking at this right here and I take out a negative from my numerator, I'll have a negative parentheses x squared minus 4, okay? It's still the same. Everything is still the same right now. I'm just manipulating. It's called algebraic manipulation. And now you can see, oh, there's my difference of squares. The negative is still out here. This negative is still out in front. But now I can factor that difference of squares to be x plus 2 and x minus 2. And it's all over the original common denominator that I had, which looked like this. And now you can see up here where you were trying to cancel these, which you cannot cancel when they're written like that. And the reason why you can't is because subtraction order matters. 2 minus x is not the same as x minus 2. Just like 1 minus 3 is not the same as 3 minus 1. Okay, so subtraction order matters. Okay, the same with division, order matters in some respect. So that's why we had to do this clever GCF out a negative 1 to get from this step to this step here. And then we did a difference of squares, which was the x squared minus 4. And now look at this. We have multiplication here, 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 and here. So I can cancel between multiplicative pieces. So the x minus 2 goes away with the x minus 2. There's a cancellation form, of 1. Okay? Not 0, because that's adding and subtracting. This is multiplication and division cancellation to forms of 1. So all that you have left over, so if you say that like this goes away and this goes away to 1, the only pieces I have are a negative 1, an x plus 2, and then in the denominator a 2 and an x. Well, nothing else reduces. We know this 2 cannot cancel with this 2 because this 2 has addition and this 2 has multiplication. Remember, multiplication pieces only, an all or nothing without x plus 2. So my answer will be either a negative x plus 2 like this over 2x, or an x plus 2, we could put the negative on the bottom if we wanted to, okay? Or we could have put the negative way out in front of the entire fraction, which would look like this. Now remember, when it's in front of the entire fraction, it's saying it's either interpreted as distributing on the numerator or the denominator. What you will see most often is if you see something that looks like this, chances are you're going to interpret it as distributing into the denominator piece, the numerator piece, that is. So when I distribute this, its most simplified form, this will look like a negative x minus 2 over a 2x. This right here, 9 out of 10 times, is the way you're going to write your most simplified form. Now we know restrictions. So restrictions, we know that this one right here, is x cannot equal 0. And we're looking at this right here, my final answer. But then if I go back, just like in other problems, and I start to see what could x not equal to, I want to go where my most common denominator piece showed, either here or even these pieces here. Well, x cannot be 0 or 2, just like it couldn't be 0 or 2 over here. So for the answer here, it cannot be 0 or 2. And if you want to write it like this, or if you want to write it separate, those are your restrictions. Okay, so review, rewind if you need to. Very important as far as those parentheses. I'm going to highlight those again on this next example. Okay, so difference. We know we're subtracting. Okay, two rational expressions. We have two rational expressions because we have two fractions, two ratios. So first step, we need to see what can cancel reduce. So to see what can cancel reduce, we got to break it up into a lot of multiplicative pieces. Okay, aka factor. So we're going to factor, and it looks like the only piece that can factor is this one right here. Everything else is going to stay the same. X plus 3 over x minus 2 minus 6x minus 7 over, let's see what this factors to. It'll be x minus 2 and x minus 1. Now we immediately look at the denominators, and we see right now they're not common. So we are missing a piece right here that should be an x minus 1. So we need to create a form of 1 fraction. So here's my form of 1, x minus 1 over x minus 1. Remember, when you multiply anything by 1, you're not changing what this equals, okay? That might be coming up right now, like you've been doing what I'm showing you to do, but the question is, why can you do a form of 1 to anything? Well, here's the reason. It's because if I had like 1/3 and I said, I want to multiply this by a form of 1. I want to multiply this by 4 over 4. Well, then I would have 4 over 12. Nah, I want to multiply it by a form of 5 over 5. Okay? Well, let's see what we would get if we multiply by 5 over 5. We'd get 5 over 15. Well, here's the thing, guys. This reduced is that. Just like this reduced still comes back to that. So all of these are still 1/3, if you will. They just are unreduced forms of 1/3. That's what's going on over here. And the reason why we do that is so that we then have a common denominator. Okay, so two fractions will become one huge fraction because they have a common denominator, which is x minus 1 and x minus 2. Now, these are the same, guys. Even though the 2's listed out first and the 1's listed out first here, they're the same because multiplication, order doesn't matter, okay? Order does not matter. We'll put it up here. Order doesn't matter with addition or multiplication. Order does matter, or we could put order matters with subtraction and division. Okay, so x minus 2 times x minus 1 is the same as x minus 1 times x minus 2. Okay, there's parentheses there. It means the same because order doesn't matter with multiplication. Okay, so now I have this that needs to distribute. Okay, I need to simplify the top just like I've done before. There's an interpreted parentheses, an understood parentheses right here around this x plus 3. So this is like a FOIL, the first, outside, inside, last. Okay, that's what's going on here. First, outside, inside, last. So the first is x squared plus 3x minus 1x, then minus 3. All I did was FOIL or distribute that first piece. Now, nothing is multiplied up here the way it was just now in the left fraction. So I'm just going to copy it. But remember, all of this is my first fraction. All of this is my second fraction. And the reason why I chose to put parentheses is because this one is highly important because there's subtraction right here. That means it will distribute on both of these. See, this one's not important because it's addition. It's not going to change the signs. Okay? So let's see what this simplifies out to. This is now x squared plus 3x minus x is now a 2x minus 3. And then now this one distributes to a negative 6x plus 7, because a negative times a negative is a positive. Again, just like before, I will not distribute the bottom, the denominator, until I'm done, until I'm finished canceling, reducing, and everything. Then I will distribute and simplify. Okay, now we can start combining like terms even more and say that this is going to be a negative 4x. So we have minus 4x. This negative 3 with the 7 becomes a positive 4. And I still have this x squared. Again, we will not reduce the bottom, simplify the bottom by distributing those parentheses until we've reduced everything. So now we have x minus 4x and x minus 4x plus 4 over x minus 1, x minus 2. So now let's see, one more ditch effort. Let's see if we can cancel this with the piece down here. So we have to set it up by factoring it out. X minus 2 is the top, okay? That's that perfect square trinomial, if you will. Okay, so this x minus 2 and x minus 2, with my original common denominator, check this out. I have one of these will cancel with that x minus 2 piece. Not both of them. You can't do one cancellation for 2, okay? Whoops. You can't do that. It's basically 1 for 1. Okay, that's that form of 1. X minus 2 over x minus 2, then this is all that remains. So my final answer will be x minus 2 over x minus 1. And now my restrictions are when throughout this entire problem could the denominator have been equal to 0, okay? So let's come over here, and my original piece right here is what I'm looking at. I know x could not equal 1 or 2, the same here and here. So 1 and 2, x cannot equal 1 and x could not equal 2 would be my answers. Because again, it's the denominators throughout the problem of when it could not equal 0. All right. So now we have 3 more slides. Let's go with the complex fractions. Okay, so these are those weird looking fractions again. And I'm gonna put all my skills together of what we've talked about in these last couple of videos and make this an easy problem. Okay, I will make this an easy problem by looking at this as 3 problems. 1, 2, and then the last one is 3. Okay, so let's first look at this numerator piece. I have 1 over x plus x over y. There we go. I'm going to go ahead and look at multiplying this. It's addition. And then xy is my denominator. Okay, so I could do this for that first piece. Let me keep it in the same color so that you know all of this was the orange part of what I highlighted before. Okay, now let's look at the denominator. The denominator is 1 over y plus 1, which is over and understood 1. And if I did 1 times 1, I'll have 1. Y times 1, I have y. I am adding, that's why I wrote this addition here. And now the product between this and this just gives me y. So now all of this is my denominator piece over here. Now we are dividing this. We're dividing everything right here. Okay, so my original, let me highlight it. My original had this division symbol right here. So we are dividing these fractions. Okay, and looking at this, it doesn't look very pretty right now. Okay, but I know if I rewrote it like y plus x squared over xy divided by 1 plus y over y, then I can use that trick from 5th grade of keep, change, flip. So it'll be keep the first fraction, change division to multiplication, and then flip these. to y over 1 plus y. Now, let's look at our pieces. I cannot cancel. A lot of people will try to cancel these y's. I can't cancel those y's because there's addition here and there's multiplication here. Okay? But this is all glued together with multiplication. It means I have all of this times y. So it's like interpreted like this over xy times this thing, 1 plus y. Notice the parentheses the way I've created them, because I know that this is all one big fraction that I can write like this, with the multiplication existing here, here, and here. Now look, now I can cancel these y's because multiplication existed in between. Okay? So I'll cancel those y's, they're gone. It's a form of 1. And what we have left is basically this right here, y plus x squared over x times 1 plus y. Again, there's nothing else that I can cancel. I cannot cancel this y and y because they're different. They are both addition, but they're both pieces of different binomial factors. So I can't cancel pieces of those. It's the whole chunk or nothing at all. I cannot cancel this and this because this one has multiplication and this one has addition. Again, only between multiplication pieces. So if I'm going to simplify this, I will distribute this x so that I don't have any more parentheses, and I'll have x plus xy in the denominator, and then I'll just have y plus x squared in the numerator. This is the most simplified reduced form. Okay, so now let's go to our fraction pieces so that we can see what could x and y never equal. Okay, so I'm going to go through this in stages, if you will. So let's find the pieces, and I'll highlight it in gray. Well, x cannot equal 0 there. Y cannot equal -1. So we'll say x cannot equal 0. X and y cannot equal -1. And we're just kind of like working our way backwards, if you will, throughout the entire problem. Okay. Let's see what else we can, and we're always going to go to the factor pieces to locate these two as well. So if I came over here, we know y cannot equal -1, which we've already accounted for. But look at this, y can also not equal 0. So y cannot be 0. Okay, we've already mentioned that x cannot be equal to 0, so that's already taken care of. If we come up here, y cannot be 0, already taken care of. Y or x cannot be 0, already taken care of. So let's just keep going back. Y cannot be 0 here, yep. And look at this denominator, x and y cannot be 0. And if I went to the original one, x cannot equal 0, y cannot equal 0, and y cannot equal 0. So all of the restrictions throughout this entire problem, those sometimes overlap, like you saw, but nonetheless, this accounts for all. We want to account for all restrictions, no matter what stage throughout the problem this was. Okay, so I don't know why I got that notification. Let's go to our next problem. We have 2 more. Again, we're going to look at this a little bit like the last problem, where we have 1, 2, and then 3 problems. Okay, so the top one, it doesn't change. It's still x. Nothing changes about that. But now let's look at the bottom piece, this 1 over x plus 1 over y. Okay, that trick shortcut that I showed you of y times 1 is y, x times 1, that cross multiplication is x. It is adding, so we'll add in the numerator, and then the product of our denominators will be our common denominator over here. Okay, so all of this was our bottom piece, if you will, our denominator piece. And it's all under x. So now we're ready for that third step, if you will, because we only have to do step 2 and 3 of this. If I put x divided by this y plus x over xy, 5th grade says that I can say keep, change, flip. So x will go on top and y will go on top, and this y plus x goes on the bottom. Now, right here, this is understood to be over 1, okay? And now if you look at it, if I combine them together, I have x, x, and y. And then I have 1 with y plus x. Now this is very important that I put these parentheses because this is a binomial. It's one big chunk. All of this is one big chunk. Now, can I cancel these y's? The answer is no, because this is a piece of a binomial with addition where this was multiplication. Okay, so it's all or nothing. Just the same, I cannot cancel these x's here. So there's nothing that I'm able to cancel. So therefore, multiplying straight across, top and bottom, simplifying and getting rid of all parentheses, I would have something that looks like this. And yes, because multiplication has no order, you could even write yx squared over y plus x. And because addition doesn't have order either, you could mix up the bottom where you say x plus y is on the bottom. And you could put x squared y or y x squared on the top. All of these are equivalent because addition and multiplication order doesn't matter. Okay, but let's go ahead and keep it as far as our final answer being this one right here. Okay, and now let's go ahead and list restrictions. Restrictions throughout the entire problem where the denominator would equal 0. Well, x cannot be 0 right here. Okay, let me highlight them as I go in gray. X cannot be equal to 0 there, there. Okay. Y cannot be equal to 0 as well. And that happened here and here. Okay. And here. And then finally, y cannot equal a negative x. Okay. And what that is saying is, if you looked at this piece right here, you're looking at y cannot be negative x. Because if y was negative x, in other words, this right here was put right here where y is at, well then I would have negative x plus x would equal 0. Okay, just like you could say x cannot be a negative y. Okay, so that's like vice versa. It's like interchangeable. X cannot equal a negative y. So your restrictions are all of these pieces here. And notice the subtle difference was that you didn't have any other numbers that were multiplying. It wasn't like 3 minus x or x plus 3. It was a variable plus another variable. That was the difference that we haven't yet had. And that's how you account for them in that respect. Our last problem, our challenge problem. Okay, a lot going on here, but nonetheless, this is still dealing with what we're working with right now. Here's how we can solve this one out. We're going to start from this piece and then move over to this entire denominator and then combine and looking at it being another denominator, because something to the negative 1 shows that it could be a piece of a denominator. Okay, so let's first do what we have here. Let me color coordinate this a little bit better so that you can follow it very, very well. Let's do this piece in blue. So 1 minus x squared, 1 minus 1 over x is the same as, I can multiply this by a form of 1, which is x over x, or you can do the shortcut. I'm just doing the long way so you can see all the steps. So that we have x over x minus 1 over x, which is going to be x minus 1 over x. That's what this in blue became. Okay? And if we have this 1, it's 1 over this. It's saying like 1 divided by this piece that we got, which is x minus 1 over x. Okay? Well, then that's the same as keep, change, flip. So we have 1 times x over x minus 1. All of this, 1 times this, is this right here. Okay? So now when I add this 1 to it, it's like saying 1 plus all of this, which is just x over x minus 1. Well, then now we're going to have to create another. We're going to have to create another, because this is over an understood one, another form of 1 where we get a common denominator. And you can rewind this and pause this if you need to. But now we can combine these two together. We can combine the top, which is x minus 1, plus x. Okay, so x minus 1 plus x. Now there's a positive 1 here, so I'm not going to write these parentheses there. I'm just going to leave them off. Again, if you need to pause and rewind, please do so. And it's over the same common denominator of x minus 1. So we have x plus x is 2x minus 1 over x minus 1. This right here just was solved from all of this. Now our running answer is that. And now it's going to be x divided by what we just got is going to be, here we go, x divided by this that we got from before is the same as 5th grade keep, change, flip. And we have this. So now, if I distribute this and multiply it, remember, you don't need common denominators to multiply. You could distribute this as parentheses, if you will, and say x squared minus x over 2x minus 1. This right now is my running answer. Let me highlight it again. All of this is all of this. And now we're going to add an x. Okay? So here we go. Let me make some room down here. We're going to take this x and we're going to add it to all of this green stuff that we just had. Well, that's over an understood 1. And if I want my common denominators to be the same, I need to multiply by a form of 1, which is 2x minus 1 and 2x minus 1. Okay? And now I can combine this by adding it with all of that. And it's all over my same common denominator of, okay, 2 fractions became 1, 2x minus 1. Let's do this first part here. That's 2x squared minus x. And then this one, nothing is distributing or multiplying, and we're adding these pieces. So we'll add this. Now remember, if it was subtraction, we would need these parentheses because it would change. But because it's not, and it's addition, we don't need those parentheses. Okay? So now let's combine like terms. Well, we have 2x squared plus x squared. That's 3x squared. Then we have a negative x minus x. These two pieces right here will become a negative 2x. And it's all over 2x minus 1. And last but not least, it's all to the negative 1 power. And guys, if you don't know this already, we've written it before, like x to the negative 1 is 1 over x. Just like if I had 1 over x to the negative 1, it would be in the numerator now as a positive. Okay? So this negative 1 makes this understood numerator, okay, let me write that better. This understood numerator over 1, it makes this piece go in the denominator. Okay? It doesn't flip. It doesn't flip. This 1 and 1, they're not the same ones that it just did like a flip reciprocal, like this, if you will. That's not what happened. There's an understood 1 and 1 on both top and bottom. So when I have this to a negative 1, this is really saying take the reciprocal of whatever is in here. Okay? So if I take the reciprocal, I would get 2x minus 1 over 3x squared minus 2x. Okay? And I'm pretty much done. The only thing that I would say from here is there a way that I can cancel anything else? Okay? So if I factored out an x from the bottom, like a GCF, if you will, I would have x, 3x minus 2, and there's nothing that I can cancel up top. Okay, 2x minus 1, that's it. I can't bring out anything other than 1. Okay, a reminder, I cannot cancel those x's because this one is tied with a subtraction or addition, and this one's tied with multiplication right here. So only through multiplication can I cancel, so I cannot cancel those. Nothing else can cancel. And because nothing else can cancel, this was the correct answer as far as my final answer. Okay? And again, make sure you don't have parentheses in your most simplified form. And that is it for your challenge problem.